two-level gate defined as cos theta e to the I pi sine theta e to the I pi sine theta, or e to the I pi, e to the I phi sine theta. I want this to be minus cos theta. So I want these two columns to be orthogonal, which I think means I mean a minus e to the minus I phi sine theta. Because cosine theta times e to the I phi sine theta with a minus sign plus e to the I phi sine theta times cosine theta, and ones along the diagonal. So this is what is defined as a two-level gate in the Nielsen and Schwang book. And let's say, suppose we could get so what I want to say is, suppose we could get that. This gate, cos theta e to the I phi sine theta minus e to the minus I phi sine theta cos theta. So this is controlled U, where U is this little matrix. So you apply a U to the last qubit if all of the first k minus 1 qubits are 1, and otherwise you do nothing. Well, then I want to claim we can get a two-level gate. Any two-level gate. Why? Well, this is just a permutation of the rows and columns of this. And we can apply U sub pi so call this a c to the k u, c to the k u. So this is the some permutation u pi dagger is equal to our two-level gate. In other words, if, so this is row 1, 1, 1, 1, 1, 1, 1, 1, 1, 0, 1, 1, 1, 1, 1, 1. To get from here to here, where this is row A, B, what we need to do is we need a permutation that takes this guy to A and this guy to B. But we can do that because we have Toffoli gates and they can produce any permutation we want. So if we have Toffoli gates and this multiply controlled U, then we can produce this. Let's let U equal cos theta minus sine theta cos theta. U to the 1/2 is equal to cos theta minus sine theta cos theta. x u to the 1/2 x is equal to, I'm sorry, theta over 2, cos theta over 2, sine theta over 2, minus sine theta over 2, cos theta over 2 is equal to u to the minus 1/2. I'm now going to write down a circuit which is going to produce u. At least I hope it's going to produce u. Okay. So this is a multiply controlled knot, or a multiply controlled X. So what happens if one of these qubits is 0? One of first qubits is 0, get, well, that means these controlled knots do nothing. So we get u inverse u, which equals identity. If all control qubits are 1, get, well, what do we get? We get x u in to the minus 1/2 x u to the 1/2 x u to the minus 1/2 x u to the 1/2 equals u. So if we can do a multiply controlled qubit, or a multiply controlled knot, which we can if we have Toffoli gates, and we can do a u to the minus 1/2 and a u to the 1/2, which we can if we have all 2-qubit gates, then we can get u, where u is any real rotation. And I haven't explained how to do complex rotations here. I mean, I haven't explained how to get these e to the I phi and e to the bits here, but I don't want to because it's along these same lines, but more complicated. Okay. Everything good so far? But I haven't explained what we do with these 2-level gates yet. I'm not going to explain it in detail. I'll just give a very quick sketch. Suppose we want an arbitrary u. Well, that has values in all. What do we do? Well, let's apply alpha, beta, gamma, delta, actually, maybe it's better if I use cos theta e to the I phi sine theta minus e to the minus I phi sine theta cos theta 1, 1, 1, 1, 1. What you can do is you can make this entry 0. And then we can by properly choosing these things. And then we can multiply, actually, I need to I phi sine theta usually I phi sine theta cos theta cos theta. So what I want to do is I want to change basis by multiplying the two-level matrix here by this guy, by another, the inverse two-matrix level. So this is T dagger equals T inverse, or T adjoint equals T inverse. And this is the matrix we want to create. You can set one of these entries to 0. And now you can keep on doing this until you get to this top entry, which then has to be unit, because we know all the columns in a unitary matrix are 1. And we can keep on setting entries to 0 by multiplying by a given two-level matrix until we get a diagonal matrix. And then, of course, to construct this matrix, we put all of these, we move all of these two-level matrices to the other side and start with this, multiply on each side by these T's and T daggers until we get this. So we can build any arbitrary matrix out of two-level matrices. And we can build any two-level matrices out of, one qubit matrices and controlled or we can build any two-level matrix out of Toffoli matrices and multiply controlled gates. And we could build any multiply controlled gate out of Toffoli gates and one qubit gates. So that explains everything except how to get Toffoli gates.